Weeks ago, we talked about the possibility that an ancient impact on Mars might have allowed for the seeding of life on Earth. Mars is still thought to have once been capable of harboring life billions of years ago, and it's thought that such an impact would have sent meteors and asteroids carrying hypothetical microbes to Earth. But the recent discovery of solid phosphorus on comet 67P seems to suggest that both comets and asteroids may contain all of the necessary elements needed for life. We're diving into what Rosetta has uncovered, and what this might mean for our model of the early solar system. But be sure to drop a like on this video, comment below even if it's just to say hi to yours truly, smash that subscribe button and ring that bell to never miss a video. I'm Eric Malachite, and this is Science Get. The elements necessary for life are humorously broken down into an acronym that even my stoned high school AP physics instructor could have memorized. CHNOPS. CHNOPS?
Chenop?
No, wait. SCHNOPS. That sounds right. We're running with that. SCHNOPS stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The majority of biological molecules on Earth are combinations of these 6 elements. Comet 67P, Churyumov-Gerasimenko, I'm so sorry if I butchered that pronunciation. Image next to me was first discovered in 1969 by Klim Ivanovich Churyumov of the Kyiv University's Astronomical Observatory. Its unique peanut, or double-lobed shape is the result of a supposed gentle impact, which stripped off material between the 2 larger pieces of the comet. Since its discovery, 67P has been of particular interest to astronomers. And in 2004, the European Space Agency launched its Rosetta spacecraft. And after 10 years, it finally arrived at its destination, comet 67P, which it would orbit at a distance of around 9 to 30 kilometers for the next few years. Consequently, due to a power failure and diminishing solar power, the ESA would lose contact with the probe 2 days after its arrival around 67P, and communication would only be briefly restored in June of 2015, until 2016 when it finally completed its mission and crashed into the comet's surface. Now, despite these troubles, the probe was able to reveal some interesting things about 67P, including the fact, which is just now coming out, that solid phosphorus was detected in the comet's tail. This is incredible news because previously we've been able to detect the other 5 CHNOPS elements in asteroids and comets throughout the solar system, while solid phosphorus has remained elusive. But just in case you're thinking that this may be a one-off, phosphorus has been found in comets before 67P. In a paper released in 1987, researchers announced that they had detected phosphorus in the dust of Halley's Comet. Now, this was most likely atomic phosphorus rather than its solid counterpart. But in 2006, NASA's Stardust spacecraft brought back samples from comet 81P Wild, revealing that the craft had collected a sample containing a single particle of phosphorus. But this time, the scientists at NASA determined that the phosphorus was most likely contained within an apatite particle, a group of phosphate minerals usually referring to hydroxyapatite, fluoroapatite, and chloropatite. However, this discovery on 67P is different. Project leader Harry Leto, no relation to Jared Leto,
As far as I know.
from the Department of Physics and Astronomy at the University of Turku said this in relation to the data. We have shown that apatite materials are not the source of phosphorus, which implies that the discovered phosphorus occurs in more reduced and possibly more soluble form. Experiments on Earth have shown that soluble phosphorus could have served a critical role in the origin of biological molecules on Earth. It's also known that there was a lack of these molecules in early history of the Earth, meaning that it is very likely that some of the impact or multiple impacts might have played a role in giving Earth the soluble phosphorus it needed for biological compounds like calcium to form. However, biological compounds are most efficiently created with reduced forms of phosphorus, and up until now, we've mostly seen this in materials left over by meteors. So scientists assume that meteors, not comets, were a likely reason for phosphorus's presence on Earth. But after the research conducted by Rosetta, it's looking like comets similar in makeup to 67P likely played an important role in giving Earth its dose of P necessary for the development of life. But there's still one problem with this idea, and it comes from the heat generated from the impacts themselves. Comets and asteroids generate tons of heat when they enter our atmosphere. If you don't believe me, just look at the footage from Chilibinks or Comet Shoemaker-Levy 9 when it crashed into Jupiter.
I'll wait.
The problem with the idea that cometary impacts could have given Earth all the soluble phosphorus it needed for organic compounds to be possible is that if a given impact was too energetic, it could have caused the materials of the comet to be changed or destroyed altogether. Though the team behind the research uncovered by Rosetta suggests that the solution to this is that early cometary impacts on Earth might have been less energetic than those of heavy meteorites, thereby preserving prebiotic materials like phosphorus. While this new research does suggest that Earth could have been seeded early on with the necessary materials for life thanks to comets and meteors, those comets must have been readily available rather than being locked away in the comet's minerals. The ESA, NASA, and other space agencies will have to conduct more missions to 67P and comets like it and return samples to Earth for further testing and examination. And luckily, that's exactly what NASA is planning to do. Similar to Comet 67P, the asteroid known as Bennu has been the subject of several studies recently. And one, conducted by Amy Simon from NASA's Goddard Space Flight Center, has shown that carbon-bearing minerals appear to be widespread on the asteroid. Since 2018, NASA's OSIRIS-REx spacecraft has been in orbit around the asteroid, and the plan was to finish the mission by landing on the surface and scooping up some rocks before finally returning to Earth so that NASA scientists could get to study them. And thankfully, it did just that. On October 20th, OSIRIS-REx landed on Bennu's surface and sucked up regolith using a blast of nitrogen gas, blowing the asteroid dust into its sample container. Now it's just a matter of waiting for the right launch window to send OSIRIS-REx cruising back to Earth. As long as that launch is successful, then OSIRIS-REx should be home in 2023. Since this mission was a success, presuming it makes it back to Earth in one piece,
We haven't blown ourselves sky high.
it's likely that NASA may greenlight some new missions to other asteroids and comets. Who knows? Maybe they'll send a follow-up spacecraft to Comet 67P. If you dug this video, be sure to drop a like and comment below to let me know who you think will be the first to land on Comet 67P. Will it be the ESA, NASA, Russia, or will it be China?
China.
And be sure to smash that subscribe button and ring that bell to never miss a Science Get episode. I'm Eric Malachite, and I'll see you next time.